What an amazing piece of work! This is great news. Astronomers using NASA's James Webb Space Telescope have found strong evidence of a giant planet orbiting a star in the stellar system closest to our own. At just 4 light-years away from Earth, the Alpha Centauri triple star system has long been a compelling target in the search for worlds beyond our solar system. Alpha Centauri, located in the far southern sky, is made up of the binary Alpha Centauri A and Alpha Centauri B, both Sun-like stars, and the faint red dwarf star, Proxima Centauri. Alpha Centauri A is the third brightest star in the night sky. While there are 3 confirmed planets orbiting Proxima Centauri, the presence of other worlds surrounding Alpha Centauri A and Alpha Centauri B has proved challenging to confirm. Now, Webb's observations from its mid-infrared instrument, MIRI, are providing the strongest evidence to date of a gas giant orbiting Alpha Centauri A. The results have been accepted in a series of 2 papers in the astrophysical journal Letters. If confirmed, the planet would be the closest to Earth that orbits in the habitable zone of a Sun-like star. However, because the planet candidate is a gas giant, scientists say it would not support life as we know it. With this system being so close to us, any exoplanet found would offer our best opportunity to collect data on planetary systems other than our own. Yet, these are incredibly difficult observations to make, even with the world's most powerful space telescope, because these stars are so bright, close, and move across the sky quickly, said Charles Beichmann, NASA's Jet Propulsion Laboratory and the NASA Exoplanet Science Institute at Caltech's IPAC Astronomy Center, co-first author on the new papers. Webb was designed and optimized to find the most distant galaxies in the universe. The operations team at the Space Telescope Science Institute had to come up with a custom observing sequence just for this target, and their extra effort paid off spectacularly. Several rounds of meticulously planned observations by Webb, careful analysis by the research team, and extensive computer modeling helped determine that the source seen in Webb's image is likely to be a planet, and not a background object like a galaxy, a foreground object, a passing asteroid, or other detector or image artifact. The first observations of the system took place in August 2024, using the coronagraphic mask aboard MIRI to block Alpha Centauri A's light. While extra brightness from the nearby companion star, Alpha Centauri B, complicated the analysis, the team was able to subtract out the light from both stars to reveal an object over 10,000 times fainter than Alpha Centauri A, separated from the star by about 2 times the distance between the Sun and Earth. While the initial detection was exciting, the research team needed more data to come to a firm conclusion. However, additional observations of the system in February 2025 and April 2025, using directors' discretionary time, did not reveal any objects like the one identified in August 2024. We are faced with the case of a disappearing planet. To investigate this mystery, we used computer models to simulate millions of potential orbits, incorporating the knowledge gained when we saw the planet, as well as when we did not, said PAAHDAADEDDDHEHE student Aniket Sanghi of Caltech in Pasadena, California. Sanghi is a co-first author on the 2 papers covering the team's research. In these simulations, the team took into account both the 2019 sighting of the potential exoplanet candidate by the European Southern Observatory's Very Large Telescope, the new data from Webb, and considered orbits that would be gravitationally stable in the presence of Alpha Centauri B, meaning the planet wouldn't get flung out of the system. Researchers say a non-detection in the second and third round of observations isn't surprising. We found that in half of the possible orbits simulated, the planet moved too close to the star and wouldn't have been visible to Webb in both February and April 2025, said Sanghi. Based on the brightness of the planet in the mid-infrared observations and the orbit simulations, researchers say it could be a gas giant approximately the mass of Saturn, orbiting Alpha Centauri in an elliptical path varying between 1 to 2 times the distance between Sun and Earth. If confirmed, the potential planet seen in the Webb image of Alpha Centauri would mark a new milestone for exoplanet imaging efforts, Sangi says. Of all the directly imaged planets, this would be the closest to its star seen so far. It's also the most similar in temperature and age to the giant planets in our solar system, and nearest to our home, Earth, he says. Its very existence in a system of two closely separated stars would challenge our understanding of how planets form, survive, and evolve in chaotic environments. If confirmed by additional observations, the team's results could transform the future of exoplanet science. This would become a touchstone object for exoplanet science, with multiple opportunities for detailed characterization by Webb and other observatories, said Beichmann. For example, NASA's Nancy Grace Roman Space Telescope, set to launch by May 2027 and potentially as early as fall 2026, is equipped with dedicated hardware that will test new technologies to observe binary systems like Alpha Centauri in search of other worlds. Roman's visible light data would complement Webb's infrared observations, yielding unique insights on the size and reflectivity of the planet. Here's some of the key things that stood out to me in this article. Firstly, this discovery could be huge for exoplanet science. As I read through the article, what really stood out to me was the idea that this planet candidate, if confirmed, could revolutionize our understanding of exoplanet science. The fact that this is the closest potential exoplanet to Earth that orbits within the habitable zone of a sun-like star makes it incredibly significant. Additionally, the fact that it could be similar in temperature and age to the giant planets in our solar system opens up a whole new realm of possibilities for exploration and research. Secondly, the incredible technology and teamwork that went into making this discovery possible is truly inspiring. The James Webb Space Telescope, MIRI instrument, and the hard work of the research team were crucial in capturing the faint light of this potential planet. The use of advanced computer modeling to analyze the data and simulate potential orbits is a testament to the ingenuity and dedication of the scientists involved. The collaborative efforts between NASA, ESA, and CSA are a prime example of the incredible things that can be achieved when talented individuals from around the world come together to pursue a common goal. Another thing that stood out to me is the sheer scale and complexity of the task of searching for exoplanet. The fact that Alpha Centauri is one of the brightest star systems in the sky, and that it takes up a large portion of the sky, adds to the difficulty of capturing the faint light of a potential planet. The use of coronagraphy and other techniques to block out the light of the stars and isolate the potential planet is a remarkable feat of technology and observation. The fact that this discovery was made despite the challenges involved is truly impressive. Finally, the uncertainty and mystery surrounding this discovery are both intriguing and exciting. The fact that the planet candidate was only seen once out of several observations is a reminder that science is a process of discovery and that there is still so much that we don't know about the universe. The possibility that the planet may have moved closer to its star and become invisible to Webb in the subsequent observations adds an element of intrigue to this already fascinating story. As we await further observations and analysis, the mystery surrounding this potential planet will continue to captivate and inspire astronomers and space enthusiasts alike. And I think that's all I have to share for today. So if you enjoyed this video, please consider subscribing to my channel. Your support really means a lot to me, and I would love to have you join our growing community. Thank you for watching, and I'll see you next time.